Hello everyone. In today's video we are going to learn about the multiplication of matrices. So first we will look at what is the compatibility test for matrices. Alright, let's consider two matrices A and B such that the order of A is m by n and that of B is p by q. Now these two matrices A and B can be multiplied if and only if n is equals to p, and the resultant matrices that will be obtained will be of the order m by q. So what does it mean? Here, when I write the order m by n, it means there are m number of rows and n number of columns for matrix A, and that for B there are p number of rows and q number of columns. These two matrices can only be multiplied if the number of columns of A is equal to the number of rows of B, and the resultant matrix that we will obtain will have the same number of rows as A and same number of columns as B. So that's the compatibility test. Let us try and understand that further now. Suppose, for example, if you have a matrix A which is, suppose 1, 2, 3 and 4. So its order is 2 by 2. Then you have another matrix P whose order is 2 by 1. So are they conformable for multiplication? For that we'll have to look at what are the number of columns in A and what are the number of rows in B. So both are same, therefore A into B is possible, and we will get a matrix AB whose number of rows will be 2 and the number of columns will be 1. So finally we will get a matrix whose number of rows will be 2 but the number of columns will be 1, same as this one and this one. So when we write a general 2 by 1 matrix, that means 2 rows by 1 column matrix, then how do we write? We write it like this: A 1 1 and A 2 1. That means it has 2 rows and only 1 column. Now why do I write it like this? I write it in this way because it helps me to multiply properly. Now let's just see how I am going to multiply. So when I write A into B, so first we checked whether they are compatible for multiplication or not, and then eventually we are going to find out the product. So first we write down the matrix A 1 2 3 4 and multiply it to matrix B 5 6. Now look at this one carefully and this will help us to multiply. Okay, A11, what does it mean? First row, first column. That means the first row of matrix A should multiply the first column of matrix B. So how do we multiply? We multiply this one with 5. So we multiply 1 into 5 and then add it with 2 into 6. So when we simplify this one, this becomes our first element A11. Now what does A21 say? A21 says second row first column. That means now the row changes but the column remains the same. So what do? We multiply 3 with 5 and add it with 4 multiplied to 6. So this gives me our second element A21. Now let us simplify this one. When I simplify, 5 into 1 is 5, 6 into 2 is 12, 12 plus 5 is 17, 3 into 5 is 15, and 6 into 4 is 24. So you have 24 plus 15, that's 39. So now we got the resultant matrix AB whose order is 2 by 1. So that's how we do the multiplication of matrices. Now let's look at another case. Here I have taken a matrix P which has an order 2 by 2 and another matrix Q which also has an order 2 by 2. So let's check the compatibility. So number of columns in P is 2 and number of rows in Q is also 2. So they are compatible, and the resultant that we get PQ, the resultant matrix, will have the order 2 by 2 because the number of rows in P is 2 and number of columns in Q is 2. Now what does this one means? This one means that any two square matrices of the same order are always compatible for multiplication, and the resultant matrix will also have the same order as the square matrices. So now we will get 2 by 2 matrices. How do we write the general 2 by 2 matrix? A11, A12, A21 and A22. Now what does this one suggest? This suggests that to get the first element, we must multiply the first row of P with the first column of Q and so on. So let us now find out the product PQ. PQ is equals to, first we will write down the matrices 0, 1, 2, 3 multiplied to 1, 2, 3, 1. So what is the first thing that we do? We first find out the elements like this. So the first row is going to multiply with the first column to get the first element. So 0 into 1. 0 into 1 is 0 plus 1 into 3 is 3. Remember, none of the elements are repeated. 0 multiplies with 1 and then 1 multiplies with 3. 0 multiplies with 1 and 1 multiplies with 3. So we got the first element 1, 1. Now what does the second one say? First row but second column. That means now the row remains the same, the column changes to this one. So what we do? We multiplied 0 with 2, then write 0 into 2 is 0 and add it to 1 now is multiplied to this one. So 1 into 1 is 1. So we got the second element also. Now we go to this one. This one says second row first column. Now the row is this one, the column will be this one. So we multiply 2 with 1. 2 into 1 is 2 plus 3 into 3 is 9. Similarly, the last element A22, second row, second column. So 2 multiplies with 2, we get 4 plus 3 multiplies to 1, we get 3. So now we have got all the elements. Let's simplify and write the final matrix. So 0 plus 3 is 3, 0 plus 1 is 1, 9 plus 2 is 11, 4 plus 3 is 7. So this is our matrix, which is also a 2 by 2 matrix. I hope now this will help you understand multiplication of matrices.